Hi, I'm Jay Rosen, and this is a demonstration of Creative Pipeline AI. This is an image generator app for marketing campaigns. So you can upload images and copy for your brand, and it can generate some new images based on dimensions. This is some examples of a brand called Novapop. There's also Iron and Oak Hardware, another example brand. So you can set the copy, the brand colors, as well as have some images, some samples you can pick from a media library. And then it will use a few different AI models that you can choose to generate the image, such as Flux point 1 Dev, or GPT Image from OpenAI, and Nano Banana from Gemini. You'll need your API keys for these specific models, so you'll go to the top right in Settings, and you can select copy over your API key. For the Flux Dev, I am currently using my own server at the University of Florida, as well as for OpenAI. These are just keys you would copy over. You can select a local save folder where the files will be stored to, and they will be sorted by image size in the specific brands that you're creating. This also supports AWS, so you can upload the images to a S3 bucket. You'll need to provide your ID as well as the key, and of course the region and what the bucket name is. So I already have this set up. So at the top left, I have a button so you can upload a JSON file or YAML, as well as you can download an example. So this allows you to create your campaign. That example JSON file that I provide, you can specify your brand name, a campaign ID, the message, which will help generate the actual image prompt, and the overlay text that will appear in the image. You can set specific markets, such as United States or Mexico, audience for this campaign, and languages, EN. Products that are actually going to appear in the image, so you can have multiple products and it will create multiple images, as well as the specific ratios or advertisement sizes, so like 728 by 90 for leaderboards. And then you can also specify the image model. This currently has it set to Flux point 1 Dev, but you can set it to Nano Banana or GPT Image. If you have some colors for your brand, you can set that as well. So I have my campaign set up from that example file. I'm going to remove some of these images. Don't quite need every single image in the example, but this will be used as a reference to help it. And I'm going to set some different sizes. So you can see this is the 320, so I'll do a 728, a 320, as well as a 9 by 16. So we'll create 3 different images, and we'll use the Nano Banana Pro model, and we'll select generate. So this is now generating 3 images at once. So the more of these that you have selected, it may just take a little while. You can see one of the images just got generated. This is one of the wider images, and the text came out pretty good. It does have that can and the cherry reference still visible, and the text is legible too. You can also download it, although it is saved in the folders locally and on AWS. This is the 728 by 90. You see the text is actually quite clear. And the last image got generated. Did capture that reference image in there. We can try also the other brand that's available, Iron Oak. I'm going to remove some of these extra images. And I'll also just choose an image from the library to show that. There are toggles up here so you can filter through the different types. It's just now creating a new folder, so hey, that's pretty good. This one actually includes the person, and it has the font in the correct color scheme with the build to last, and it has that brand name. So if we want, we can download a report, and that report will include all the information that we've created. This is the report that was generated. This currently just has all of the images that were generated since I last reset this. In the future, it would be filtered for the actual campaigns. In addition, I did add support for video creation. So if you select video, you can have the option for LTX2 Turbo and VO 3.1. I'm going to set the video to 16:9 aspect ratio, and we'll just leave it as it's set right now. The video generation will take longer than the images. The video took about a minute to generate.
Built to last. Iron and Oak Pro Series Den for the pros.
The video is just an added feature. It seemed like it fit really well within this interface of generating the images. Next, we'll demonstrate multi-language support. So I'm on the Nano Banana Pro. I'm just going to choose these 3 output sizes. So this will generate multiple images. In the markets, I'll just choose United States for now, but I'm going to choose Spanish as well as Japanese and French. So we have 4 languages, 3 pictures. This should generate about 12 pictures. The multi-language support is not perfect. This one was the Japanese language, and there are some Japanese characters, and the French one does have some French, but overall I do see it looks like it's mostly using English. The pictures are coming out quite nice though. On the back end, the AWS S3 bucket did generate the images to these folders. So the Nova Pop and Iron Oak, these were the campaign names, and this was the product name. And inside the product, it does generate the actual dimension folders. I generate a lot of these 1x1s. So these are all the 1x1 images. 720x90 images, as well as composites where there were multiple images in that. And then going to Iron Oak, Power Drill product, and then 1x1s. This is the code base, and I'm looking at how the images were generated. Very similar to the S3 bucket. It goes by campaign, product, and then the dimensions of those images. So these are the images, some of them we didn't see generated. And also the videos are also stored in the same way too. When it does store the image, it does use the market and the language. I did treat this project like a hackathon, and it was prototyped rapidly in about 4 hours. So this is the GitHub of the creative pipeline. You can see from the overview that it lays out the full generation lifecycle for every product, market, language, and size combination. The app runs compliance checks, builds the model-aware prompt, and calls the selected model, applies the overlay behavior depending on provider, normalizes the result with Sharp, and saves the asset either locally or to S3. This all persists through generation history in the browser with local storage, so the gallery survives refreshes. The sequence is the backbone of the entire system. Here's the architecture diagram. The system is intentionally split into a lightweight browser client, a Node and Express API layer, external AI providers, and storage. The browser handles the campaign form, gallery state, and local persistence. The server handles routing, compliance, prompt building, provider-specific execution, and image normalization. Then the outputs are stored either in the local assets folder, exported through the File System Access API, or uploaded to S3. On the single image request flow, the main idea is that each variant follows a deterministic pipeline. Request comes in, compliance runs first, the prompt is built, and the model generates the asset. The image is normalized, storage returns a URL, and the client persists the manifest. For Flux specifically, there's an additional client-side overlay pass after generation, which is one of the main provider-specific differences in the architecture. Shown in the video demo, these are some of the screenshots of the different aspect ratios and the different campaigns, the media gallery, and the settings page. The key files, the server index is where all the express routes, AI provider adapters, compliance engine, prompt builder, which is how we, of course, create the entire image, is all generated. In the index page is where the generation orchestration happens. It iterates the products, the markets, and the language, the ratios, manage loading state, and calls the backend and persists the manifest. The campaign brief form, results gallery, and settings modal separate the input, output, review, and configuration concerns. I also centralized model definitions in shared image models, which made the provider abstraction cleaner and easier to extend. In the AI services section, one of the core design decisions was keeping a shared structured prompt model while adapting execution per provider. All providers receive the same high-level campaign intent, but the backend changes authentication, request formatting, reference images handling, polling, and response parsing depends whether the model is Flux, GPT, Image, Gemini, LTX, or VO. Here in the server index is how the prompt is constructed. The backend builds a single prompt per variant using the product, market, audience, brand color, font mood, safe zone rules, overlay behavior, and layout constraints. For GPT image and Gemini, reference images can be sent natively. For Flux, references become prompt guidance, and the final overlay text is composite afterwards in the browser using the text overlay. That split is deliberate and reflects the strength and limitations of the individual providers. The storage section shows a local first philosophy. By default, assets go to the local assets folder, but they can also be exported into a user selected folder or uploaded to AWS S3 bucket. The media library follows the same pattern, including built-in sample brand assets from Adobe Stock and uploaded references served through the API. The compliance was not fully developed. However, compliance happens before every model call, and in strict mode that requests can fail early within HTTP 422 instead of wasting quota. Those compliance results also travel with the generated variant and appear in the gallery, so the output remains reviewable. This is the campaign brief in JSON, and the aspect ratio sections show how the input scheme drives the entire system. The brief supports products, markets, and audience, language, reference, images, model selections, and compliance mode, while the ratio table maps the formats and the custom sizes into concrete output dimensions. That made it easy to support both social formats and add banners in the same pipeline. How to run the project on your computer. You'll need Node.js 1 year later, at least one of the provider API keys such as OpenAI or Gemini or Flux. You'll use npm install, and then you'll create a .env file and put your local host as the API base URL. It will run with npm run dev, and you will see the process for the front end on 8080 and the back end on 8787. Some of the most important design decisions in the project were about extensibility, practical user experience, and keeping the prototype close to something that could scale into production. The first big decision was using a model registry in the shared image models. Instead of hard-coding provider logic throughout the app, every model is mapped to a small metadata record, provider, request model, display name, and whether it supports native reference images. That means adding a new model is mostly a single registry change, and both the front-end selector and back-end execution path pick it up automatically. Another important choice was attaching reference images per product rather than globally. In a real campaign, different products often need different creative grounding. With this design, one product can use a lifestyle photo reference while another product in the same campaign generates entirely from prompt text. That makes the system much more flexible for mixed product workflows. The prompt construction is also adaptive. The build prompt function logic supports 3 modes: a full campaign message plus overlay text only, or no message at all. So the system can work whether the user provides a detailed creative brief or just lightweight product information. For Flux specifically, I handled text separately in the text overlay, where the overlay renderer computes font size dynamically from the available canvas area. That keeps narrow formats like skyscrapers readable instead of using fixed size text treatment that would break. I also made compliance run before any API call. That prevents wasted quota and gives immediate feedback if strict mode checks fail. On the client side, I persist the full gallery manifest in browser local storage so the user can refresh or reopen the app without losing generated results. I use the same local first mindset for credentials. Keys stay in the browser storage and are passed only per request, so the server never writes secrets to disk. In terms of limitations, this is a proof of concept. History is browser local, and keys are not managed through a secret service. Some providers have external constraints like cold starts or billing requirements, and extreme aspect ratios may require resizing compromises. But the architecture scales cleanly. The next steps would be replacing synchronous generating with a job queue, moving the manifest into a database, moving assets into object storage, introducing secret management, adding multi-tenant brand support, and extending the modal registry with routing, fallback, and reporting logic. So overall, the core design goal was to build something lightweight and usable now while structuring in a way that naturally evolves into production grade creative pipeline.